Hey guys, what's going on? It's Dave from Evil Eye Games. Today's video, I want to discuss something that kind of irks me a little bit. In the wake of several games that have been released recently, we've seen a lot of commentary on people watching the game who've never played the game and make ridiculous statements and misuse one word in particular. And that word is optimization. So in this video, I want to talk about what is game optimization, what it does, and how people misuse it so much. So before we actually get into talking about what game optimization really is, I want to dispel a couple of myths that are commonly used when describing game optimization on the internet. And the first thing is that if two games run on the same engine, they should perform the same. Behind the scenes of making a game and creating all of the assets that go into a game, there are so many variables, it's mind-blowing. So aside from the actual game engine that's being used, you have things to keep in mind like poly counts, texture qualities, the materials that are used to make the surfaces look like they do. You have all kinds of different particle effects going on. And you have not only the quality of these things, but also the quantity of these things being used. So directly comparing two games just because they run on the same engine is absolute nonsense. The second myth I'd like to point out is that if a game runs poorly on some set of hardware, it is poorly optimized. And this just highlights the case of people not understanding or knowing what game optimization actually is. There's a huge difference between a poorly designed game and a poorly optimized game. And secondly, a lot of the people who make these claims also use very arbitrary or hidden standards on which they make these determinations. I mean, to be quite honest, there's no real set standard as to what determines how well a game runs. Now, this is going to vary from people to people, and it's going to vary from platform to platform as well. For example, if you can run a game on console at a solid 30 frames per second, you're going to have an awesome running game. Some people on PC are fine with running games at 30 frames per second, no problem. Some people on PC are going to require that a game runs at above 60 frames per second. Other people are going to be like, I have to run the maximum amount of frames that I can run at all given times in order for me to not be dissatisfied with a product. So the standards for which we classify a game running well are really all over the place. Now, the first thing we have to talk about when we talk about game optimization and development of a game in general is that the company developing the game is going to have target hardware that they're going to want to run the system on. Now, with the ubiquity of consoles, most big game companies out there are going to be targeting consoles as their primary target. So generally speaking, right now, the weakest game console is going to be the Xbox One. So running a game on the Xbox One console at 30 frames per second is going to be a high priority for a lot of these companies. And then the game company is also going to have a target to how good they want the game to look. And of course, this is going to vary based on the type of game that they're making. There's going to be a big difference between the performance goals of running a competitive first-person shooter versus running an RPG. So the standards by which the game companies are going to make these games are going to shift up based on the game that they're making. Now, once the company has an idea of the target hardware that they want to run the game on and how well they want the game to look, they're going to have to basically run a balance as they create the game between looking good and performing well. So along the way, the game developer is going to make some calls where they're going to either take looking good over performing well or vice versa, and that is going to shape the overall outcome of the game itself. But one thing to point out is this is not game optimization. This is a design choice. And really, when it comes down to game optimization really honestly has very little impact on the game overall. If you have a game that runs well and is designed well from the very beginning, optimization basically is just tweaking the system to squeeze a little bit of extra performance out of what you can. So you have a game that on a top tier system is running 20 frames per second at 1080p, even though you're running a Titan X. no level of optimization is going to get that game to run well. It has nothing to do with optimization. It is all about really bad game design. And one of the very important things that we want to talk about too is the graphics settings and graphics optimizations. Now, when it comes down to optimizations for graphics, the majority of optimization comes from tweaking the settings of the preset graphical settings. Basically, what you're looking at is setting up the settings within the menu so that they can run at different levels. Now, one of the big things to recognize when we're talking about graphic settings is consoles generally run at 1080p. Although the PlayStation Pro now runs a fake 4K, it's not real 4K, but the goal is still really going to be 1080p because that's the vast majority of what people are playing on. Even on PC systems, something like 90% of gamers are running at 1080p or less. And most importantly, what they're going to look at when they're setting up these presets for the game is they want to maintain a steady frame rate within their goal. Now, your personal arbitrary goal of it has to run at 60 frames per second is not the developer's goal. And in fact, the goals between developer to developer are going to be different. And the last thing I want to point out is that most of the game settings are focused around the medium setting. Not the high, not the very high, not the ultra epic, super mega uber setting, whatever. The medium setting is the core gaming experience that the developers are aiming for. Anything beyond medium, in general, is just for show. So most people out there are running a graphics card that runs somewhere in the $150 to $200 range. But of course, there are people out there who spend the $1,200 on buying a Titan X, and they want something to show for spending $1,200 on their Titan X. So the settings in those very high, super high, mega ultra high settings are for show, and for the people who have high-end hardware, it gives them something to show off with their system. In general, the highest settings are not what the game is designed to run on. And a lot of the time, these ultra-high settings as well will include a lot of experimental or new cutting-edge features that are not running in the lower-edge versions because they still aren't necessarily running very well. One particular example of this is when the game Crysis originally launched. One of the things Crysis introduced was volumetric lighting. But the implementation of volumetric lighting at the time was very poor compared to what we have it now, and it was extremely demanding. It's one of the things that Crysis used to bring systems to its knees when it was launched. Since then, the implementation of volumetric lighting has improved a lot, although volumetric lighting still is very resource hungry. But the difference between volumetric lighting from when Crysis launched and now is actually significantly different. So if you really want to be objective about how optimization in the graphics department is done, really you're looking at running a game at 1080p on the medium settings. And the goal is to get a game that runs consistently at those settings. Anything beyond those settings is extra plus, something on the side to make it look better if you spend a little more money. Now, aside from graphics optimization, there's also the actual gameplay code optimization. And this is basically done by streamlining actual game logic in order to make it perform a little bit better. And this differs from the graphics optimization in the fact that in the graphics optimization department, you're trying to squeeze out some extra while using the same amount of resources. Within the code optimization, you're looking at reducing the amount of resources being used to accomplish the same exact goal. And this code optimization actually provides the least amount in actual gameplay performance if the code is done competently to begin with. Usually, you're looking at reducing the amount of CPU instructions used. You're looking at the amount of time that the processor uses to calculate all the different functions within the game. And most of the time, these optimizations come at a great cost-to-benefit ratio. So say you have a function within your game and it uses 3% of the processor time. you could spend an entire month trying to optimize this function and get it down to only using 1.5% of the processor time. But when you get down to brass tacks, you just use a month to increase the game performance by 1.5%. And generally speaking, unless you're doing something like an ultra-realistic simulation, or you're doing a lot of physics simulation, CPU usage in games really isn't that much and isn't that much of an issue. So a lot of the times when it comes down to code optimization within games, honestly, very little is actually done. And finally, the last general type of optimization that we can look at is gameplay optimization. And your gameplay optimization is going to focus on improving the experience for the player. So your gameplay optimization is going to get no real benefit to the performance of the game itself. But this is where the game company focuses on improving controls for the player, and they try to improve the actual game flow as well. They'll do things like fix up the UI and the menu-based systems. They'll create better save load systems or optimize what they're saving and loading and when they save and load, and improving netcode for network games. And basically, this is all completely experience-based for the player so that they have the best time when they play the game that they can. So something like saying there is something in the menu system that the player has to use pretty frequently during the course of play. If they have to keep going to that menu, but they have to go through like 8 or 9 different menus to get there every single time, that's going to be really obnoxious for the player, and it's going to deter from their experience. You want to make sure that the player is engaged in the game and that everything kind of moves from one thing to another in a very smooth fashion. So just to summarize what we covered here, there's 3 real types of optimization that can occur within games. We have the graphics, and the biggest part about the graphics optimization is usually going to revolve around making sure that those preset settings function reasonably well, and most importantly, the medium setting, because that's what most players are going to be using based on the most popular hardware out there. Then we have code optimization, where we actually streamline the actual game logic and improve the performance of the game logic itself, which is going to provide the least in actual gains. And finally, we have the gameplay optimization itself, where we make the most streamlined experience for the player possible. Now, with all of these things taken together, you're not going to get a game that's running at 30 frames per second, make these improvements, and all of a sudden your game is going to be running at 60 frames per second on the same settings. That's not how it works. It's all about taking what you have and squeezing a little bit extra out of what you already have there, and about making the experience as smooth as possible for the player. So the next time you see a new game launch and everybody jumps on the bandwagon to call out that a game is poorly optimized, instead of saying that a game doesn't run at their arbitrary standards, you can know better than they do. So hopefully you guys got something out of this video today. If you have any questions or comments, you can go ahead and leave them down below. And you can also check out my Facebook page. I'll leave a link down in the description for that, and you can message me over there. And as always, guys, thanks for watching.